Hi, I'm Steve Michon. I'm here with Zero Tolerance, and today we're going to go over the basic fundamental measuring tools for a mold shop. One is going to be calipers, 0 to 6, and then we're going to talk about micrometers. One of the things about micrometers and calipers is when you first see these tools, you think they're super accurate or you don't really know what they do. I'm going to probably have to show you on the whiteboard how accurate these can be, but I'm just going to explain it verbally first. Your calipers, which is going to be these, are going to be very useful to measure the insides of objects or parts or detail. You can do it as a depth mic to see how far something is. And this will show you an accuracy about a thousandth, a half to a 1/1000 of an inch, which is the third decimal place for 1/1000. The fourth decimal place would be your half-thou, the 0.0005. Micrometers, on the other hand, these you should be able to measure within 2/10 of a thousandth, which is the fourth decimal place, being 1/10. But if we look at this very closely, you can see if I go to 0, you'll see how these go to 0. The first thing you'll notice is if they're not to 0, that means your micrometers might be dirty, have something in them, or may need to be calibrated or corrected so that they do read 0 when they go to 0. I'm going to talk about calipers a little bit more. For a mold maker, this is technically, in my opinion, a reference tool. It's really not to get any kind of quality numbers. You can get good at it, but you're eventually going to want to check it either with a CMM or you're going to go to micrometers. Micrometers are going to be in the shop all over the place, but you can get a good reference number from here for the outside of this, for the inside of the thread, and this is how you would do it. You put your thumb on here, and it allows you to get a good feel for what that is. I wouldn't recommend it for an actual measurement for any kind of quality. It's simply for your reference to make sure that that is pretty close. I do want to show you, for example, what I mean. So this is a Joe block. It's exactly a 1/2 inch thick, and I'm going to use my calipers, and what I want to show. Okay, so here's the 1/2 inch Joe block. It's exactly a 1/2 inch within a 1/10. So I'm going to use this, and it's going to show pretty close. And depending on how hard I squeeze it, you can see that number can change. So that is just a feel. That's why I say reference when you're talking really tight tolerance stuff. You always move to a micrometer to do the same measurement, and this you'll be able to get a better measurement and a better feel. But this sometimes takes some experience to really know what that feels like. But that's how you do it. You can feel it move. It's not over tight, but you could still do the same thing. You can over tighten this and get a bad reading. So it's all about the feel of it. This is your gauge. You know how big that is, and if this lines up and it's calibrated right, you're going to have a lot better luck getting really accurate numbers. I would say plus or minus 2/10. And on the micrometer itself, it actually shows the tenths back here. So each one of these lines is a 1/10, which allows you to line it up. Let's say we're going to go 1/2 inch, and then if you look at what this lines up as over here, then that will be your call out for the tenths. One of the main things I see in a shop, if you're starting off and you're new, calipers and tools and micrometers can fall and hit the ground. And once that happens, you cannot trust that tool until it's recalibrated, checked for damage, or you can verify that the 1/2 inch Joe block, and Joe blocks are a great tool to just get a good reference. Hey, did I break my tool or my measuring device? Did I wreck it, or is it off? So that's what you want to do. If anything falls or you drop it on accident, double check it, make sure they're right, and if they need to be repaired, get them repaired. I gotta mention is the different ratchet systems they have on some of the micrometers. These are Mitsutoi, and they have this ratcheting here. This one has more of it doesn't make any noise. Don't mind my thumb, I smashed it. But what you'll find is this is a 2-inch Joe block, and I have a 2 to 3 inch micrometer right here. So I'm going to go to 0, and what I wanted to mention is I could give this to 3 different people to measure something that we made in the shop, and I could get 3 different dimensions. So always as a check for final inspection is use a Joe block so you can get your feel correct. Check the ratchet too, because that may or may not give you a good answer. You may need to have a better feel just by experience. If we were measuring something like this and you're doing a lot of measurements, these digital version of this micrometer helps you to see those tenths a lot easier than using a standard micrometer that just is reading off a dial. So this is very close to 3/4 of an inch. So this insert is that big. The pocket that it goes in is got to be a lot, very close to that, but it has to be bigger for it to go in there. For example, if we wanted to check the inside of this pocket, since we don't have inside micrometers, you can get a variation of numbers. We know for sure, based on this insert, that this pocket is bigger than 3/4 of an inch, but it's showing on my calipers that it's not. That's why I say it's a reference. So it depends on how you feel it, but it's probably more likely a half thou over. And the best way to check this pocket would be to use the Joe blocks. So to truly check this, this is a 3/4 inch or 0.750 Joe block, and it goes in there nice. So now I'm going to try 751, 1 thou clearance, and we'll see if that goes in. I can't get it to start. So we are going to go into the tenths of the Joe block set to see exactly how big that pocket is. We are going to take the 750 and 4/10 and see if we can get it to start. Oh, it goes in. Okay, so that's 4/10. Let's try 5/10. So exactly a half thou over, and that's what it is. That's snug because it doesn't just fall. It's starting to be snug in here. So that's super close. That's 2.5 tenths aside. I'm going to go 1 more tenth up. 6 tenths over. And I can barely get it to start. And it goes in. So that's 3/10 aside clearance in here. I would say it's 0.7506. 3/10 aside clearance, and then that block falls in there. All right, we want to do 1/10 bigger just to make sure that this doesn't go in. So this is 750 and 7/10. You know, I should have white gloves and everything being perfect, but we're talking about being in a shop, and that's just not how it is. Yeah, that doesn't. I can't get it in. You can probably squeeze it in or hammer it in, but it's not going in. So I'm gonna go back and say that it's 0.7506, 3/10 per side clearance to allow our nameplate to go in the pocket like so. One very important thing I didn't mention, I did it if you noticed the video, but make sure when you're about to measure something, you wipe off those surfaces that are actually the measuring surfaces. And you can notice if there's dust in there by shutting it and it having a number outside of 0 on there. So always make sure you wipe it. I even recommend doing it on your micrometers, is wipe that off, get the dust out. And this is simply to try to be as close to 0 tolerance as possible. If you've never used Joe blocks before, there's one thing I didn't mention. I think I did do it if you watch. The surface finish on these Joe blocks are super fine, and they're made to have like 0 space in between them when you stack them. So the whole point is that you can put it on there and it'll fall off. But if you actually put it on there and you squeeze the air out from in between them, it won't come off. It's technically stuck on there with just a vacuum. Just to prove the point that this is super accurate. So this is not magnetic at all. It'll fall. And this is a pretty heavy piece of steel, a 2-inch Joe block. I'm going to squeeze this one and the 1/2 inch stays, but let's see if the 2-inch stays. And that's not magnetized. Pretty impressive. So before you take a measurement, make sure you squeeze the air out of that and then do the measurement if you have to put a stack together to get to that perfect size that you're trying to measure. I was asked how do you read the micrometer? So one revolution on a micrometer is 25 thousandths. So we're going to go one revolution, which is 25 or close to it. And that's the first line on past zero is 25 thousandths. So in 1 inch, you have 40 revolutions, which 40 times 25 is 1,000, which is 1 inch. So as you go, you have 1 thou, 2 thou, 5 thou, they're marked that way. And they go 15, 20, then it goes back to 25 or 0. And then the next mark will be 50. I think I passed it. So 50. Then you get 75. It's like quarters. And then you get to 100 thousandths. So you can see it on the digital readout, but looking at it here, if you don't have digital, that's how you read it. And then the farther you go, so on. 125. So you get to 1/8 of an inch per 25 thousandths per revolution.